Today we'll discuss BStat and BMaths Objective 2019 paper for admission into ISI, which is Indian Statistical Institute. Now, most of the questions in this paper, they are absolute delight and fun. So we'll straight away dive into the questions. And the first question is, you are given a 4x4 chessboard and you are asked to fill it with 5 3x1 pieces and 1 1x1 piece. Then over all such fillings, find the number of squares that can be occupied by 1x1 piece. Now what do we have? We have 5 3x1 pieces. Now we can arrange 4 3x1 pieces horizontally and then 1 3x1 piece vertically. Now we know that in this case, these 6 squares, they'll always be occupied, and these 2 squares, they'll also be occupied. Now with this, either it can be first 3 or it can be either last 3. Now if we occupy first 3, then in that case we know that this one will be here, and for the last one either it'll come here or it'll come here. So in that case there'll be 2 squares available for 1x1. So if we're going to place it here, then we have this square, and if we'll place the fourth one here, then we'll have this square for 1x1. Now what if we place fourth one here like this way? So we'll place it this way, then this topmost, it can be arranged in these 2 ways. So either I'll have this square free or this square free. So that means overall we'll have 4 places where I can put this 1x1 piece. So answer to this question is simply 4. If we'll take the vertical lines also, so if we'll take 4 vertical squares and 1 horizontal, then too we'll get these 4 corner pieces. So in either case, answer will always be 4 squares. Now question number 2, it's a standard Bayes theorem question. Now it says, a brand called Jogger's Pride produces pair of shoes in 3 different units that are named U1, U2 and U3. So we have 3 events. So either the product will come from U1 or U2 or U3. Now these units produce 10%, 30% and 60% of total output. So that means probability of getting a product from U1 is 10 by 100, U2 is 30 by 100 and U3 is 60 by 100. Now it says total output of the brand with the chances that a pair of shoe being defective is 20, 40 and 10 respectively from U1, U2 and U3. So that means we are also given that the probability that a product is defective, if it comes from U1, it is 20%, which is 20 by 100. Probability that it is defective if it comes from U2, it is 40 by 100. And probability that it is defective and it comes from U3 is 10 by 100. Now it says, if we randomly select a pair of shoes from combined output, and we know that if it is defective, what is the chance that the pair was manufactured in unit 3? So that means we need to find that it comes from U3 if the pair of shoes is defective. So we know that in Bayes theorem, so we'll put this case in the numerator, which is probability of U3 into probability of D upon U3. We'll put all the possibilities where we can get this product defective, which is PUI into P D upon UI. So in the numerator, we'll have 60 by 100 into 10 by 100, and the denominator I'll write 10 by 100. So 10 multiplied by 20, so into 20 by 100 plus 30 by 100 into 40 by 100, and then finally 60 by 100 into 10 by 100. So I can cancel these hundreds and I can also cancel these zeros also. So what I'm left with is 6 here, and here will be 2 plus 12, 14, 14 plus 6, 20. So that is 6 upon 20. So this is 3 by 10. So answer to this question is simply 3 by 10, which is simply 30%, and that's your option number A. Now question number 3, it says, consider a paper in shape of an equilateral triangle ABC with circumcenter O and perimeter 9 units. So that means length of the side is simply 3 units. If we fold the paper in such a way that each of the vertices A, B and C gets identified with O, then find the area of the resulting shape in square units. So if we fold this, so suppose A comes here. In the same way, we'll write it for B. And we'll fold C also. So we need to find area of the resulting shape. So we need to find area of this shape. Now we know that length of the side is 3 units. We can find length of this altitude. So length of altitude AD will simply be A, and this angle is 60. So that is A sine 60. So it will be 3 root 3 by 2. Now we can find AO. So we know that AO upon OD is 2:1. So this AO will be 2 upon 3 times, and this is 3 root 3 by 2. So I'll cancel this. So value of AO is simply root 3, and we can say this point is suppose G. This length, it is equal to the other length. So that is AG is equal to OG. So that means I can write this AG as simply under root of 3 by 2. Now this half angle, it is 30 degrees, and suppose length of the small triangle is L. So I can write L cos 30 equals root 3 by 2. So that is the value of L is simply 1. So now we know that it will be an equilateral triangle. So if I find area of this triangle, so area of this small blue triangle will be root 3 by 4 into 1 square, and we have 3 such triangles. So if we have to find area of resulting figure, it will be area of this equilateral triangle which is given ABC, and minus 3 times area of these 3 small triangles. So this is root 3 by 4, and in this case length of the side is 3, so there will be root 3 by 4 3 square, and then 3 into, now here it will be simply root 3 by 4. So it will simply be 9 minus 3 is 6, so it is 6 root 3 by 4, or 3 root 3 by 2 square unit, and that's your option number C. Now question number 4, it says if P is a regular 12-sided polygon, then find the number of right angle triangles formed by vertices of P. Now they have not given the figure, so for the reference I have taken this figure from the internet. So it's a dodecagon. So we have to find 3 vertices so that they form a right angle triangle. We know that these points, they lie on a circle. So if I choose 2 points which are diametrically opposite points, then if I choose any other point, then we know that angle in a semicircle is 90 degrees. So in all such cases, the triangles that will be formed, they'll be right angle triangles. So first I'll need to choose 2 diametrically opposite points. So in how many ways can I choose these diametrically opposite points? So I can choose it in 1, 2, 3, 4, 5 and 6 ways. So it can be done in 6C1 ways. Now if I select these 2 points, suppose I select this one and the other point. Now how many right angle triangles can be formed? So I have to choose any one point out of 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. If I choose any one point out of these 10 points, then these 3 points will always form a right angle triangle. So simply there'll be 10C1, so which is simply 60. So number of right angle triangles that can be formed is 60. That's your option number A. Now question number 5, it says if the n terms of an AP with incremental r, so that means we are given this common difference which is r, then the difference between mean of their squares and squares of their mean is. So we have to find difference between mean of their squares and squares of their means. So I'll write any general term. So any general term, suppose AK, it is given as A1 plus K minus 1, and D here is simply R. Now if I'll square it, AK square will be A1 square plus R square into K minus 1 square plus twice A1 R into K minus 1. So first I'll find sum of their squares. So sum of the squares when K varies from 1 to N. So there'll be this summation A1 square, then summation R square K minus 1 square plus summation twice A1 R into K minus 1. So now this is simply A1 square, and this is summation of constant is simply N. So there'll be A1 square into N. Now plus, now here R square is constant. Now this is K minus 1 square. So there'll be 0 square plus 1 square plus 2 square up to N minus 1 square. So there'll be N minus 1 N 2N minus 1 whole divided by 6, and then plus twice A1 R, and here it is 0 plus 1 plus 2 up to N minus 1. So that is sum of first N minus 1 natural numbers. So that is N minus 1 N by 2. Now it says difference between mean of their squares. So that is sum of their squares. So what is the mean of their squares? So mean of their squares will be simply summation AK square by N. So it will simply be A1 square plus R square N minus 1 2N minus 1 by 6, and then plus here 2 and 2 will cancel. I'll get A1 R into N minus 1. So that is mean of their squares. Now we'll also need to find square of their means. Now square of their means will be this summation AK upon N whole square. Now what is summation AK? Summation AK will be simply N by 2 twice A1 plus N minus 1 into D, which in this case is R, upon N, and then whole square. So here N and N will cancel. So I'll get 1 by 4, and this is 4A1 square plus N minus 1 square into R square plus 4A1 N minus 1 into R. Now I can divide it with 4. So I can write A1 square plus N minus 1 square R square by 4, and then plus A1 N minus 1 into R. Now we need to find difference between mean of their squares and squares of their mean. So this difference will be MSQ minus this squares of their mean. So here this is A1 square plus R square N minus 1 2N minus 1 by 6 plus A1 R N minus 1, and then minus here it is A1 square plus N minus 1 square R square by 4 and plus A1 N minus 1 into R. Now in this case, this A1 square will cancel and A1 R N minus 1 will also cancel. So what I'll get is, so here I'll take R square common and N minus 1 by 2 common. So I'll take R square N minus 1 by 2 common. Then I'm left with 2N minus 1 by 3. And then here I'll get N minus 1 by 2. So it'll be R square. This is N minus 1. And then 4N minus 3N. So that should be N. Then minus 2 plus 3. N plus 1 by 12. So it should be R square N square minus 1 by 12. And that's your option number C. Now question number 6, it says, a father wants to distribute a certain sum of money between his daughter and his son in such a way that both of them invest their shares in the scheme that offers compound interest at 25 by 3% per annum for T plus 2 years. If the two shares grow to become equal, if the son's share was 4320, we need to find total money distributed by the father. So suppose he gives P amount to his daughter. Now what is the amount that his daughter is entitled to after these T years? So it will be 1 plus and then 25 by 300 to the power T. Now it is equal to the amount that his son will get after T plus 2 years. So this is 1 plus 25 upon 300 to the power t plus 2. So this is p, and then this is 325 upon 300 to the power t, and this is 4320, 325 upon 300 to the power t plus 2. So this p simply will be 4320, 325 upon 300 whole square. So this p comes out to be 5070. So the amount that this man has given to his daughter is 5070. Now they are asking for total money distributed. So total money will be 5070 and plus 4320. So that is 9390 rupees. And that's your option number B. Now question number 7, it says, let alpha be a real number. We need to find range of values of mod alpha minus 4 such that mod alpha minus 1 plus mod alpha plus 3 is less than or equal to 8. So we'll take 3 separate cases. Case 1, when alpha is less than minus 3. Case 2, when alpha lies between minus 3 and 1. And third case, when the value of alpha is greater than 1. So when alpha is less than minus 3, in that case, both these expressions, they are negative. So I'll write minus alpha plus 1 and then minus alpha minus 3 is less than or equal to 8. So I'll write minus 2 alpha is less than or equal to 10, or alpha is greater than or equal to minus 5. But this result, it comes with the condition that alpha should be less than minus 3. So from here we'll get the condition on alpha is the value of alpha should be greater than minus 5 but less than minus 3. Now for the second interval, we know that this alpha minus 1 will be negative and alpha plus 3 now will be positive. So we'll get minus alpha plus 1 and then plus alpha plus 3 is less than or equal to 8. So alpha will cancel. I'll get 4 is less than or equal to 8, which is true in this given interval. So from the second part, the condition I'll get is the value of alpha should lie between minus 3 and 1. Now for this third part, both the definitions, they'll be positive. So we'll get alpha minus 1 plus alpha plus 3 is less than or equal to 8. So which is 2 alpha is less than or equal to 6. That is alpha is less than or equal to 3. So from here, I'll get the condition that alpha should be greater than 1 but less than or equal to 3. Now if I'll combine all the 3 conditions, because these conditions are connected by OR, then I'll get the value of alpha should lie between minus 5 and 3. Now we need to find range of values of mod alpha minus 4. So if I'll subtract 4, I'll get minus 9 is less than alpha minus 4 is less than minus 1. And if I'll take mod sign, then I can write 1 is less than or equal to mod of alpha minus 4 is less than or equal to 9. So what is the range of mod alpha minus 4? So range of mod alpha minus 4 is from 1 to 9 and both included, and that's your option number C. Now question number 8, it says, for each natural number k, choose a complex number zk such that mod of z is equal to 1, denoted by area ak of the area of triangle formed by zk, iota zk and z plus iota zk, then which of the following is true for the series below. Now they have not given this figure, so I have taken this figure for the reference. So what they have given is, they have given 3 complex numbers, z, iota z and z plus iota z. Now we know that we can write this iota as e to the power iota pi by 2 using Euler's form. So this is z and this is z into e to the power iota pi by 2. So that means this second iota z is formed by rotating z by an angle pi by 2 in anti-clockwise direction. So that's your z, and here will be iota z. Now if we'll use addition of complex numbers, then we can get z plus iota z also. Now we look at this triangle which is formed by z iota z and z plus iota z, then it will be a right angle triangle, and also this is mod z and this is mod of iota z, which again is mod of z. So it will form an isosceles right angle triangle. So what is the area of this triangle? So area of this triangle will simply be 1 by 2 into mod of z square, which simply is 1 by 2. Now it says we need to find this summation, which is summation k varies from 1 to infinite, and this is ak to the power k. So that means this is simply k varies from 1 to infinite, and this is 1 by 2 to the power k. So this is 1 by 2, 1 by 2 square, 1 by 2 cube up to infinite. It is nothing but an infinite GP. So sum of an infinite GP is a upon 1 minus r, which is 1. So sum of the series is 1, so which is a finite value. It simply means this series, it always converges. So that's your option number C. Now in question number 9, it says this function is y equals e to the power kx. So if I'll differentiate, I'll get y dash as k into e to the power kx, and then second derivative will be k square into e to the power kx. So now I'll take this equation. So this second derivative will be k square e to the power kx, dy by dx is k into e to the power kx. This again is k into e to the power kx, and then minus e to the power kx, and this is y, which is e to the power kx into y dash, which is k into e to the power kx. So I'll take this e to the power kx common from both the expressions. So I'll cancel this e to the power kx square from left hand side and right hand side. So here I'll get k square plus k, and here I'll get k minus 1, and here will be k into e to the power kx whole square. So I'll cancel it. Now e to the power kx, it cannot be 0, so there is no root loss. Now here I'll take k common, and I'll write k, and this is k square minus 1 into k. So from here, one solution that I'll get is k equals to 0, and then I'll get k square minus 1 equals to 1. That is value of k is plus or minus root 2. So this function satisfies this given differential equation for 3 distinct values of k. That's your option number C. Now in question number 10, it says we are given 2 simultaneous equations. Then we have to find number of solution to this equation in x and y. And then we have to choose one of the following options. So it says cos theta into x minus sin theta into y is equal to 1, and then sin theta into x plus cos theta into y equals 2. So what I'll do is, in the first equation, I'll multiply it with cos theta, and I'll multiply the second equation with sin theta, and I'll add them up. So if I'll multiply, I'll get cos square theta and plus sin square theta, which is 1, minus sin theta, cos theta, I'll cancel. So I'll get x equals cos theta plus 2 sin theta. So that is the value of x. Now we'll multiply this first equation with minus sin theta and second equation with cos theta. Then minus sin theta, cos theta, I'll cancel. And here I'll get sin square theta plus cos square theta, which is 1. So then I'll get y as minus sin theta and plus 2 cos theta. So the solution for this system of equations will be this x and y. They should be cos theta plus 2 sin theta, and then minus sin theta plus 2 cos theta. So for any value of theta, we'll get unique value of x and y. So answer should be, there's only one solution to this system of equations. Now question number 11 says, in this range from 0 to 2 pi, we have to find number of solutions of this equation, which is cos of sin x is equal to 1 by 2. So we know that 1 by 2 is simply cos pi by 3. So I'll write general solution for cos. So there'll be sin x equals 2n pi plus or minus pi by 3. Now if I'll take n as 0, I'll get sin x as plus or minus pi by 3. Now pi by 3 is nearly 1.05 something. So now sin theta, it cannot be greater than 1. So that means this equation has no solution. So number of solutions is simply 0. So that's your option number A. Now in question number 12, it says a particle is allowed to move in xy plane by choosing any one of the 2 jumps, that is either move 2 units to the right and 1 unit up, or move 2 units up and 1 unit to the right. Now they have given 2 points, which is P 30,63 and Q 100,100. So if particle starts at origin, then we need to find it can reach which of the given 2 points. Now what we'll do is, now suppose the particle which is at origin, it takes m jumps in jump 1 and n jumps in jump 2. So this step it takes m jumps, and for this it takes n jumps. So after these jumps, the coordinate of this point will be, so now after m jumps in this direction, so there'll be this plus 2m, so there'll be 0 plus 2m, and then n jumps will also add plus n, and the same way in the y coordinate it'll be this m, and then here it is plus 2n. So after these steps, so the coordinate that this point can have is 2m plus nn, m plus 2n. Now first we look at this point P, which is 30,63. Now particle will reach at this point when 2m plus n is 30 and m plus 2n is 63. So if I'll add them, I'll get 3 times m plus n. This is 93. So from here I'll write m plus n equals 31. So if I'll subtract this equation from the first one, I'll get value of m as minus 1. Negative value for m and n, it's not allowed. So that means this particle, it can never reach this point P. Now what about point Q? Now for this point Q, which is 100,100, so I'll get 2m plus n equals 100. m plus 2n is also 100. So we'll add them, I'll get 3 times m plus n equals 200. So that is m plus n is 200 by 3, which is not an integer. That means it cannot reach Q also. So answer should be neither P is reachable nor Q is reachable. So that's your option number B. Now it says for a real polynomial in one variable P, let ZP denotes the locus of points x and y in the plane such that Px plus Py is equal to 0. Then there exist polynomials Q1 and Q2 such that it is a circle and parabola, not a circle or parabola, or circle but not parabola, parabola but not circle. Since in all the 4 cases we are discussing parabola or circle, so that means this polynomial, it should be a quadratic polynomial. So that is az square plus bz plus c. So now the given condition is px plus py is 0. So px plus py is equal to 0. So if I write px, so there will be a x square plus bx plus c, and ay will be ay square plus by plus c equals to 0. So here I'll get a x square plus y square, b x plus y, and plus 2c equals 0, which is x square plus y square plus b upon a x plus y plus 2c upon a equals to 0. So which is equation of a circle, and it cannot represent equation of a parabola. So answer to this question will be, so ZQ is a circle, but it cannot be a parabola. So which is your option number C. Now in question number 14, it says we are given a 4th degree polynomial, and it says P0 is 1, P1 is 2, P2 is 3, and P3 is 4. We need to find the value of P4, and we also know that this leading coefficient is 1. So I can actually write this Px as x into x minus 1, x minus 2, and x minus 3. So whenever I'll put P0, P1, P2 or P3, so in that case all of them they'll be 0, and then plus. So if it is 0, then it is 0 plus 1, 1, then it is 1 plus 1, 2 plus 1, and then 3 plus 1. So this is plus x plus 1. So if I'll put 0, I'll get 1. If I'll put 1, then it'll be 0, I'll get 2. So that is the polynomial that we are talking about. Now here it is asking for the value of P4. So value of P4 simply will be 4, 3, 2, 1, and then plus 5. So it'll simply be 24 plus 5 is 29. So answer to this question is 29. That's your option number C. Now in question number 15, it says there is a function which is differentiable and derivative is 0 at exactly 2 distinct real numbers, alpha and beta. Then which of the following option is correct? Alpha and beta are the points of local maxima. Alpha and beta are the points of local minima. One must be local maximum, other must be local minimum. And the 4th condition is given data is insufficient to conclude about either of them being local extremum points. So if it is given that the derivative is 0 at 2 distinct points, then these two distinct points, they may be point of inflections, they may be maxima or minima, they may be inflection or maxima, inflection or minima. So no information can be concluded from the given condition. So it has to be option number D, which is given data is insufficient to conclude about either of them being local extremum points. Now question number 16 says a school allowed the students of a class to go to swim during the days March 11 to March 15, 2019. What is the minimum number of students that class should have that ensures that at least 2 of them went to swim on the same set of days? So we need to find out how many distinct set of combination of dates can be formed from these given dates, that is March 11th, 12th, 13th, 14th and 15th. Now for each date, a student has 2 options. Either he or she will go for swimming or he or she won't go for swimming. So for this date, there are 2 options. For this date also 2 options. For this also 2, and then 2, and then 2 here. So which is 2 to the power 5. So for any given student, there are 32 choices. If we have 32 students in a school, then each of the student may have distinct set of dates for which he or she can go for swimming. So the minimum number of students that class should have to ensure that at least 2 of them went to swim on the same set of dates is 33. So the school should have at least 33 students. Question number 17, it says we need to find 4 increasing numbers A1, A2, A3 and A4 such that this summation, which is 1 upon A1 plus 1 upon A2 plus 1 upon A3 plus 1 upon A4, it should be 11 by 6. Now we know that 1 plus 1 by 2 plus 1 by 3 and this value is equal to 11 by 6. So that means I need to at least replace one of them to get this summation as 11 by 6 with 4 numbers A1, A2, A3 and A4. Now if I'll sum 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5, then this sum is nearly 1.28, and we know that 11 by 6 is nearly 1.83. So this sum is less than 11 by 6. Now if I choose any number n which is greater than 5, then 1 upon n will be less than 1 upon 5. So if I replace any of these numbers with 1 by n, in that case this sum will still be lower than 1.28. So it can never be equal to 11 by 6. So which simply means one of the number has to be 1. So we are sure that this A1, it should be 1. Now what about this second number? Now suppose I'll say the second number is not 2. Then if I'll choose other 3 numbers, which is 1 by 3, 1 by 4 and 1 by 5, then I'll get this sum as nearly 1.78, which again is less than 11 by 6. And again, if I replace any of these numbers with n greater than 5, then this sum will always be less than 11 by 6. So that simply means this second number, it should be 2. So now we have this 1 and then plus 1 by 2. Now this third number, it cannot be 1 by 3, because if it is 1 by 3, then we'll get 11 by 6 with sum of 3 numbers. So that means I have to skip this 1 by 3, and then suppose this one is 1 by 4, and then I'll have this other one which is A4. Now this is 11 by 6. Now if we'll solve this one, then we'll get this is 4 plus 2 plus 1, and this is 1 upon A4, and it is 11 by 6. So from here I'll write 1 upon A4 is 11 by 6 minus 7 by 4, and this is 12, 22 minus 21, so it is 1 by 12. I'll get value of A4 as 12. So that means A1 is 1, A2 is 2, A3 is 4, and A4 is 12. So these are the 4 numbers, 1, 2, 4 and 12. Now we need to find A4 minus A2. So A4 minus A2 is simply 10. That's your option number B. Now question number 18, it says there are 3 children and 2 adults. They want to cross a river using a rowing boat. The boat can carry no more than a single adult, or in case no adult is in the boat, a maximum of 2 children. We need to find least number of times the boat needs to cross the river to transport all 5 people. So we have this river. Then initially we have 3 children and 2 adults and boat is here, right? So we need to transport all these 5 people across the river, and we have to find the least number of times the boat needs to cross the river. Now first 2 children must go there. So here we'll have 2 children and here we'll have 1 child and 2 adults. So now boat is here, right? Now thereafter 1 child row the boat back. So now we'll have 2 child and then 2 adults, and here we'll have 1 child. Now 1 adult will row. So this is 1 adult, 1 child, and here I'll have 2 child and 1 adult. Now this child, he's going to come back with the boat. So now we'll have 3 child and 1 adult. Now again 2 child, they'll go. So 2 child, 1 adult, and boat is here again. And here it is 1 child, 1 adult, and again 1 child comes back. So it is 2 child and 1 adult. And here it is 1 child and 1 adult. Boat is here. Now 1 adult will go here. So now we have 2 child here, and this is 1 child, 2 adult, and boat is here. So again 1 child, it is going to come back here. So it is 3 child. Now boat is here and we have 2 adults there. So now 2 child, they'll cross. And then 1 child is going to come. So this is 2 child, and then finally 2 child, they'll cross the boat. So how many times we need to cross the river? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So the least number of times the boat needs to cross the river is simply 11. Now question number 19, it says, let M be 3 cross 3 matrix with all entries being 0 and 1, then all possible values of determinant of M is. Now suppose we have this matrix M, which is A1, B1, C1, A2, B2, C2, A3, B3, C3, where each of these AIs, BIs and CIs, they are either 0 or 1. So now if we look at determinant of M, we know that determinant of M can be 0. So if I'll choose all the entries as 0, so then in all such cases determinant will be 0. We also know that this sum can be plus 1 or minus 1. So if I'll take identity matrix, then I'll get plus 1. And if I interchange any one row or any one column in identity matrix, then it'll be plus or minus 1. Now we need to find out whether or not I can have these values plus 2 or minus 2, plus 3 or minus 3. I'll find this determinant M. So determinant of M will be, so this is A1 and this is B2C3 minus B3C2 minus B1. So it is A2C3 minus A3C2 and then plus C1, which is A2B3 minus A3B2. So if I'll rearrange, I can write A1B2C3 plus B1 C2 A3 and then plus C1 A2 B3 and then minus A1 C2 B3 plus B1 A2 C3 and then plus C1 B2 and A3. Now we know that each of these ABCs, they can take value either 0 or 1. So value of each of this product AI, BI, AI, BJ and CK, it can take only 2 values, either 0 or plus 1. Now I need to think if I can get the value of this determinant as 3. So I'll get this value as 3 if I get all these 3 terms as 1 and all these 3 terms as 0. But it is not possible because here in this case, this product will be 1 when all these numbers A1, B2, C3, B1, C2, A3, C1, A2, B3, they all have to be 1. And if they are all 1, then here also it'll be 1. It can't have a value 0 in that case. So the value of this determinant, it cannot be plus or minus 3. So then what is the next best case? So next best case is when we have 2 of them as 1 and third one as 0. Now if I choose all these 3 as 0, so like C1 is 0, A2 is 0 and B3 is 0. So in that case, this is 0, this is 0 and this is 0. And if I'll choose all these other values A1, B2, C3, B1, C1, A3 as 1. So in that case, I'll get this value of determinant as 2. And if I simply interchange two rows, then I can also get -2. So the possible values of these determinants are 0, +-1 and +-2, which is your option number B. Now in question number 20, it says ABC is an isosceles triangle with an inscribed circle with center O. Let P be midpoint of BC. If AB equals AC is equal to 15, so this is 15 and this is also 15, and BC is 10, so that means this value is simply 5. So this is 5 and this is 5. Now we need to find length of OP, which is nothing but radius of in circle. So we can find this perpendicular, which is AP. So AP simply will be under root of 15 square minus 5 square. So that is 225 minus 25. So that is under root of 200. So it will be 10 root 2. So what is the area of this triangle? Area of this triangle is half AP, which is 10 root 2 into base BC. BC is simply 10. So it will be 50 root 2. Now what is semi-perimeter? S is 15 plus 15 plus 10 divided by 2, which is 20, and we know that R is simply delta upon S. Now R in this case is 50 root 2 and this is 20, so it will be 5 upon root 2, and that's your option number B. Now in question number 21, it says we are given this function fx, which is x upon x plus 1, which we can write it as f1x, and then each successive composition is fnx. So then we need to find this value f1 minus 2, f2 minus 2 and fn minus 2. So we know that f1x is x upon x plus 1. Now if we'll find f2x, so it will simply be f of f1x, so it will be x upon x plus 1 and then x upon x plus 1 plus 1, so it will simply be x upon 2x plus 1. In the same way, f3x, so it will be f of f2x, so it will be x upon 2x plus 1 and then x upon 2x plus 1 plus 1, so it will be x upon 3x plus 1. So we'll continue like that. Then we can write f and x should be x upon nx plus 1. Now if we'll multiply them, then we can write this as f1x into f2x into fnx. We can write this as this product, which is x upon rx plus 1, where r varies from 1 to n. So if we'll put x as minus 2, then we can write f1 minus 2, f2 minus 2, fn minus 2, and it will be this product r varies from 1 to n and minus 2 and then minus 2r plus 1, or this product r varies from 1 to n and this is 2 upon 2r minus 1. So if I'll put r as 1, I'll get 2 upon 1 and then 2 upon 3, 2 upon 5, and it goes up to 2 upon 2n minus 1. So this product will be 2 into 2 into 2 n times, so there'll be 2 to the power n, and then upon product of first n odd numbers, so which is 1, 3, 5 up to 2n minus 1. That's your option number A. So question number 22, it says we are given this series expansion, which is 1 plus x squared to the power 27. This is a0, a1, a2 and then a54. We'll need to find a0 plus a3 plus a6 plus a9. So that is, we need to find the coefficients in which the power of x is a multiple of 3. So we know that 1 plus omega square is 0 and omega cube is 1, where omega is complex cube root of unity. So what I'll do is, so here first I'll put x as 1. So if I'll put x as 1, I'll get 3 to the power 27, and here will be a0, a1 plus a2 plus a3, a4 plus a5 plus a6. Now we'll put x as omega. So if I'll put x as omega, I'll get 1 plus omega square to the power 27, and here will be a0, a1 omega, a2 omega square, a3 omega cube, a4 omega to the power 4, a5 omega to the power 5, a6 omega to the power 6. Now this is a0, this is a1 omega, a2 omega square. Now omega cube is 1, so it will be simply a3. Now omega 4 is omega cube into omega, so which is a4 omega, a5 omega square, and then again omega to the power 6 is 1, so a6, and here 1 plus omega square will be simply 0. Now I'll put x as omega square. So if I'll put x as omega square, I'll get 1 plus omega square plus omega to the power 4 square. So here will be a0, a1 omega square, a2 omega to the power 4, a3 omega to the power 6, a4 omega to the power 8, a5 omega to the power 10, a6 omega to the power 12, and the series will continue. So now we know that omega to the power 4 is simply omega. Now 1 plus omega square is again 0. Now this is a0, this is a1 omega square. Now omega to the power 4 is simply omega. So this is a2 omega. Omega to the power 6 is 1. So this is a3. Then a4. Omega to the power 8 is omega to the power 6 into omega square. So it will be omega square. Then a5 omega and plus a6. Now if we let these three results, then I'll get 3 to the power 27. Now here it will be a0 plus a0 plus a0. So there will be 3 times a0. Now plus this is a1 omega and a1 omega square. So 1 plus omega square will be 0. In the same way a2 omega square and a2 omega will again be 0. Now this is a3 plus a3 plus a3. So this is 3 times a3. So in the same way all other terms will be 0 except for terms containing powers of x which are multiple of 3. So it will be 3a0, 3a3, 3a6. So we'll divide everything with 3. So then I can write a0 plus a3 plus a6, and this series as 3 to the power 26. Answer to this question is 3 to the power 26, which is option number A. Now question number 23. If an examination has 20 questions, for each question the marks that can be obtained are either -1, 0 or 4, and if S is the set of possible total marks that a student can score in an examination, then we need to find total number of elements in set S. So that is, if in a question a student can get either -1 or 0 or +4, and there are 20 such questions, what are the possibilities of total marks that the student can score? So one way of solving this question is, for each question we know there are 3 possibilities. Either a student will score -1 or 0 or 4, and we can express it by this simple polynomial, which is either a student will score 0, so which is represented by this term x to the power 0, or -1 or 4. So that is, for each question there are 3 possibilities, and which are 1 upon x plus x to the power 4. So total number of ways of scoring on this question will be 1 plus 1 upon x plus x to the power 4 to the power 20. Now in order to find all possible total marks that a student can score, we need to find number of distinct terms in this expansion. Number of distinct terms in the given expansion. Now, how do we find number of distinct terms in this expansion? So I cannot use that formula n plus r minus 1 cr minus 1, because it is applicable only when the variables are unrelated or distinct. So what I'll do is, I'll write this expansion 1 plus 1 upon x plus x to the power 4 to the power 20 as x to the power 4 plus 1 plus 1 upon x to the power 20. And if I'll use binomial expansion, I can write r varies from 0 to 20, 20 cr x to the power 4, 20 minus r, and 1 plus 1 upon x to the power r. Now if I'll expand this series, I can write this series as 20c0 x to the power 80, 1 plus 1 upon x to the power 0, 20c1 x to the power 76, 1 plus 1 upon x, 20c2 x to the power 72, 1 plus 1 upon x whole square, 20c3 x to the power 68, 1 plus 1 upon x to the power 3, and then plus this summation where r varies from 4 to 20 x to the power 20 minus r into 1 plus 1 upon x to the power r. Now here I'm not interested in the expansion of this series. So what I'm interested in is number of distinct terms. So what I'll do is I'll just count what are the powers of x they'll be present in this expansion. So this expansion will have x to the power 80. Then here we'll have x to the power 76. And if I'll multiply it with 1 upon x, I'll get x to the power 75. Then from this one, now 1 plus 1 upon x, it will have 1 upon x and 1 upon x square. So here I'll get x to the power 72, x to the power 71, x to the power 70. Now with 68, I'll have 1 upon x, 1 upon x square and 1 upon x cube. So here I'll get x to the power 68, x to the power 67, x to the power 66, x to the power 65. And hereafter we know that this r is greater than 4. So it will contain these 4 consecutive terms. So 1 upon x to the power 0, x to the power 1, x to the power 2, x to the power 3. So from here we'll get all the consecutive powers of x. So starting from 68, we'll get all the consecutive powers of x up to this 1 plus 1 upon x to the power 20, and there I'll get x to the power minus 17, x to the power minus 18, x to the power minus 19, and x to the power minus 20. So in this expansion, I'll have these terms starting from x to the power minus 20 to x to the power 68, and then we'll have these 6 more terms. So now I'll need to count number of distinct terms in this expansion. So I know that from 80 to 20, it'll be total 80, and then plus we also have x to the power 0 and then plus 20. So that's 101. And then minus, what are the missing terms? Missing terms here are 77, 78, 79, 73, 74, and then x to the power 69. So that is, there are 6 terms which are missing. So 101 minus 6, so that is 95. So the total number of elements in set S is 95. So there are 95 different possibilities in which the student can score in an examination. Now in question number 24, it says, chords AB and CD of a circle intersect at right angle to the point P. The length of AP, PB, CP and PD are 2, 6, 3 and 4. We'll need to find radius of the circle. So I'll take a circle and then I'll take 2 perpendicular chords. Now suppose this is AB and this is CD and they intersect right angle at point P. So this is P. Now it says AP is 2 and PB is 6. So this is 2 and this is 6. And the same way CP is 3 and PD is 4. Now we need to find radius of this circle. So what I'll do is I'll take the center. Suppose the center is O. Now length of CD is 4 plus 3, 7, and length of AB is 6 and 2, 8. So this length will simply be 4 and this length will be 7 by 2. Now if I'll find this length also, then what is this length? This length will be 7 by 2 minus 3. So this is 7 by 2 minus 3. So it is simply 1 by 2. So this length is 1 by 2. This length is 4. So if I have to find radius of this circle, then radius of this circle simply will be under root of 1 by 2 square plus 4 square. So it is 1 by 4 plus 16. So it will be under root of 65 by 2. And that's your option number B. Now question number 25 is, we need to find locus of points x comma y so that sine square x plus sine square y is equal to 1. So I can write it as sine square y equals 1 minus sine square x, and which is sine square y equals cos square x. Now we can write this cos square x as sine square pi by 2 minus x. Now this is sine square theta equals sine square alpha. So we can write general solutions. So its general solution will be y equals n pi plus minus and then alpha. Alpha here is pi by 2 minus x. So we can write this equation as plus minus x plus y equals n pi plus or minus pi by 2 where n belongs to z. So this locus, it represents straight lines with slope either plus 1 or minus 1, and for different values of n we'll get different set of lines. So this equation will represent, or this locus will represent, infinitely many lines with slope plus or minus 1, and that's your option number C. Now question number 26, it says we need to find number of integers n greater than 10 such that this product nc10 into n plus 1 c10 is a perfect square. So we'll write this product, which is nc10 into n plus 1 c10. So this is nc10, and n plus 1 c10 we can write it as factorial n plus 1 factorial 10 and factorial n plus 9. I can also write it as nc10, and this is n plus 1 into factorial n factorial 10, and this is n minus 9 into factorial n minus 10. Now factorial n upon factorial 10, factorial n minus 10 is nothing but nc10 again. So I can write this as nc10 into nc10 n plus 1 upon n minus 9. So we can write it as nc10 whole square into n plus 1 upon n minus 9. So now we can say that this product nc10 into n plus 1 c10 is equal to nc10 whole square into n plus 1 upon n minus 9. Now the product of binomial coefficients, it is an integer. N plus 1 upon n minus 9, it may be a fraction where the denominator part gets cancelled by nc10 square. So we cannot assume n plus 1 upon n minus 9 as some k square. If we'll assume it as k square where k is an integer, we won't get any solution, and that is not the answer to this question. So what we'll say is this n plus 1 upon n minus 9, it should be a perfect square of some rational number. So it should be of the form p square upon q square. Now we need to find the value of n so that I can express it in the form of p upon q whole square. Now another way of looking at the problem can be, we can write this as n plus 1 into n minus 9, and it should be p square into q square. So this product, it should also be a perfect square for same values of n. So if I'll multiply them, I'll write n square minus 8n minus 9, and this should be equals to some k square where k is an integer. Now if I'll complete the perfect square, I'll write plus 16 and minus 16. So I'll get n minus 4 whole square minus 25 equals k square, or n minus 4 whole square equals 5 square plus k square. Now it forms Pythagorean triplet. Now the only Pythagorean triplet containing 5 is 13 square equals 5 square plus 12 square. So from here we can say the value of n minus 4 should be 13 and value of k should be 12. So here the value of n is simply 17. So the only value of n for which this expression nc10 into n plus 1 c10 is a perfect square is n equals 17. So if I'll take n equals 17, then this n plus 1 upon n minus 9 will be simply 18 upon 8, which is 9 by 4, which is 3 by 2 square. So it is a perfect square, but it is a perfect square of a rational number, which is not an integer. So answer to this question is number of integral values of n is simply 1. That's your option number B. Now in this question it says 2 to the power a plus 2 to the power b minus 2 to the power c is equal to 144. Then we need to find the value of a plus b minus c. Now we know that this c is less than or equal to b and this b is less than or equal to a. So here I'll take 2 to the power c common. So I'll write 2 to the power a minus c plus 2 to the power b minus c and then minus 1, and here it is 144. So if I'll express this 144 as prime powers, then it'll be 2 to the power 4 into 3 square. So if I'll compare this c with 2 to the power 4, so I'll get the value of c as simply 4, and then I'll need to find 2 to the power a minus c plus 2 to the power b minus c minus 1, and this should be equals to 9. Now we know that we can write this 9 as 8 plus 2 minus 1, which is 2 cube plus 2 minus 1. So we'll compare. I'll write a minus c as 3 and b minus c as 1. So value of c here is 4. So value of a is 7 and value of b is 5. So a is 7, b is 5 and c is 4. Now we need to find a plus b minus c. So that is 7 plus 5 minus 4, which is simply 8. So answer to this question is 8, which is option number B. Now question number 28 is we need to find number of integers n for which this cubic equation has 3 distinct integral solutions. So if I take this as some function fx, I'll write this as x cube minus x plus n. And if I'll differentiate, I'll write f dash x as 3x square minus 1, and if I'll put it equals to 0, I'll get x as plus or minus 1 by root 3. So this is minus 1 by root 3 and this is plus 1 by root 3. So rightmost is positive, negative and positive. So derivative changes sign at minus 1 by root 3. So here it is local maximum, and at 1 by root 3 it will be local minimum. Now this cubic equation, it will have a local maxima at minus 1 by root 3 and a local minima at plus 1 by root 3. So it'll start from minus infinite, it'll take its maximum value and then it'll take its minimum value at plus 1 by root 3, and that value should be negative. Only then it can have 3 real roots. Now it says this equation has 3 distinct integral solutions. So that means the only integral solution possible between minus 1 by root 3 and plus 1 by root 3 is 0. So this graph, it must pass through x equal to 0. So if this equation has 3 distinct integral solutions, then one of the solution must be x equal to 0. So if we'll take x as 0, then the value of n should be 0. So in that case, we'll get this equation as x cube minus x is equal to 0. So the 3 roots are 0 and plus minus 1, and then there is no other value of n possible. So number of distinct integral values of n is simply 1. So this equation will have 3 distinct integral solution only when the value of n is 0. So which is your option number B. Now question number 25, it says we need to find number of real solutions of the equation x square equals e to the power x. Now in this question, we just need to find number of real solutions and not the solutions itself. So we can solve this question using graph. So we can draw the graph of exponential function and we can draw the graph of y equals x square. Now a common mistake that a student can make in this question is, so we generally draw this exponential function, and then if we draw this x square, then they may say these two graphs, they intersect at 2 points. So number of solutions in this case is 2, which in this case is completely wrong. Now we know that exponential function increases rapidly as compared to x square. So if we have to draw the graph of x square, suppose that's your graph of x square. And suppose this is the graph of exponential function. Now exponential function increases rapidly as compared to x square. So these two functions, e to the power x and x square, they'll never intersect when x is greater than 0. So they'll have only one point of intersection. So number of real solution of this equation will be only 1 and not 2. Now question number 38 says, we have to find number of distinct real roots of this equation, which is x sin x plus cos x is equal to x square. So what I'll do is I'll take this function fx as x sin x plus cos x and minus x square. So if I'll differentiate this function f dash x, then I'll get x, derivative of sin x is cos x, and then plus sin x, cos x is minus sin x, and then minus 2x. So here sin x and sin x, it will cancel. So I'll take x common, and then it will be cos x minus 2. So if I'll put it equals to 0, so there is only one critical point, x equal to 0. Now cos x cannot be equal to 2. So this is 0. Now when x is greater than 0, so this is positive and cos x is always less than 2. So this is negative. So it will be minus and then it will be plus. So this function will have a local maxima at x equal to 0. Now what is the value at 0? So if I'll put x as 0, then in that case, so this is 0, x square is 0, so f0 is 1. So now these plus and minus signs, they also indicate that this function will increase when x is less than 0 and will decrease when x is greater than 0. So if I'll take this limit x tends to minus infinite x sin x plus cos x and minus x square. So minus infinite will contribute to this higher power of x. So this value will be minus infinite. So this function will start from minus infinite, and in the same way, if I take this limit x tends to plus infinite, so again this minus x square, so I'll take it towards minus infinite, so it'll end at minus infinite. So this function will start from minus infinite, it'll increase, it'll attain its maximum value at 0, and then it'll start to decrease, and then when x is infinite, this value is again minus infinite. So this graph, it will intersect x-axis at two distinct points. So number of distinct real roots of this equation is simply 2, which is your option number B.
If you like the video, consider subscribing and sharing it with someone you know who might benefit from it. Also, the best way to navigate any topic is through a playlist. Simply go to the channel page, click playlist, and select the topic you wish to study.